Hey everyone, and welcome. We all know electric vehicles are pretty smart, right? But the next huge leap forward isn't just about bigger batteries or faster acceleration. Nope. It's about something we do dozens of times a day without even thinking about it: braking. Today, we're going to dive into how AI is turning the simple act of stopping your car into a powerful way to create energy. I know, it sounds a little bit like magic, doesn't it? I mean, braking is supposed to be about losing energy, about stopping. But inside an electric vehicle, it's a huge opportunity. It's this incredibly clever process where hitting the brakes actually helps recharge your battery. And as we're about to see, AI is getting ready to give this tech a massive, massive upgrade. So here's the basic idea. When you lift your foot off the accelerator in an EV, the electric motor completely flips its job. Instead of using electricity to make the wheels go, the momentum of the wheels starts spinning the motor. And just like that, the motor becomes a mini generator, turning all that forward motion, that kinetic energy, back into electricity that flows right back into the battery. Okay, so here's our game plan for this explainer. First, we'll look at why today's smart braking isn't quite as smart as it could be. Then we'll see how AI is giving it a serious upgrade. We'll peek under the hood at the different AI tricks being used, check out the actual numbers on how much energy is saved, and finally, we'll look into a wild future where cars talk to each other to save even more power. Regenerative braking is, without a doubt, a brilliant concept. But the way it works right now, well, it's not quite living up to its full potential. There are some pretty big limitations that are holding it back from being as efficient as we want it to be.
Just look at this comparison. It shows a completely different philosophy. Your old school brakes are all about brute force, using friction to turn your car's momentum into wasted heat. Seriously, that's all they do. But regenerative braking is way more elegant. It captures that momentum and turns it back into usable energy. Plus, your brake pads barely have to work, so they last way, way longer. It really is a win-win.
But, and this is a big but, here's the catch. These conventional systems are kind of clumsy. They don't work very well at really low speeds because there just isn't much energy to capture. If you have to slam on the brakes in an emergency, they can't handle it alone. The car has to fall back on the old friction brakes anyway. And maybe the biggest issue is that they use a fixed, one-size-fits-all approach. They don't care if you're on a wet road, a steep hill, or towing a trailer. And the result? Well, in typical city driving, you're recovering less than half of the energy you possibly could. So how do you fix this? Well, this is where artificial intelligence and machine learning come into the picture. Instead of a dumb system that just follows a few simple rules, AI gives the braking system a brain, one that can see, predict, and adapt, all in real time.
So how does that even work? Think of the AI as your personal co-pilot, and it's constantly analyzing everything. It learns your specific driving style. Are you an aggressive driver or a cautious one? It knows exactly how much charge is in the battery, and it's aware of the road conditions. So instead of just reacting when you hit the brake, it's already predicting the perfect amount of braking force to maximize energy recovery without ever compromising on safety.
This quote right here really nails it. Dynamically adjusting force distribution. What that really means is the AI is making thousands of tiny decisions every second. How much braking should come from the front motor? How much from the back? Do we need to blend in a little friction brake? The result is not just more energy, but also a safer stop and a much smoother ride for you.
So what's actually going on inside this mechanical brain? How does it think? Well, it's not just one single piece of code. It's actually a whole toolbox of different AI techniques working together. Let's pull out a couple of the key players.
Okay, fuzzy logic is so cool because it works a lot like we do. It's less about hard numbers and more about, common sense. A normal system might have a rule like, if speed is below 10 kilometers per hour, turn off regen. But fuzzy logic thinks more like, the speed is kind of low and the driver is braking gently, so let's apply a small amount of regenerative force. That flexibility gives it much smoother and smarter control. Then you've got reinforcement learning. The easiest way to think about this is like teaching an AI to play a video game. The goal of the game is to brake as efficiently as possible. Every time the AI makes a really good decision, one that saves a ton of energy while keeping the car perfectly stable, it gets a reward, like points. If it makes a bad decision, it gets a penalty. After running millions and millions of these simulations, it learns the absolute best strategy for any situation you could imagine. It's always getting better. And the AI toolbox gets even bigger. You have things like neural networks, which are designed to find patterns just like a human brain. There are genetic algorithms that literally evolve better braking strategies over generations of simulations. And even swarm intelligence, which finds the best solution by acting like a colony of ants working together. It's a whole team of AI specialists, all focused on perfecting the act of stopping. All right, I know this all sounds super advanced and technical, but what does it actually mean for your car's performance? What's the payoff? Let's get to the numbers because honestly, they are seriously impressive. Check this out, a 59% improvement. Researchers found that by using machine learning to predict the best braking force, they could capture up to 59% more energy compared to some of the standard methods out there. That is a gigantic leap in efficiency, and it translates directly into more miles of driving range from the exact same battery. And you don't even need the most complex models to see a big difference. Just by using fuzzy logic, that human-like reasoning we just talked about, one system improved its overall energy efficiency by over 22%. It just goes to show that even a single, smarter AI approach can totally change how a car saves power. This chart here makes it really clear, especially for city driving. The bar on the left is a standard, rule-based system. It recovers about 54% of the possible energy. Not bad, but look at the bar on the right. That's an AI-optimized system. It bumps that recovery rate up to 63%. That extra 9% is just free energy, found by simply braking smarter. As amazing as all this is, it's really just the starting line. The next huge wave of innovation will come when we move beyond just making a single car smart and start creating an entire ecosystem of connected, intelligent vehicles. The future is all about connection. With something called Vehicle-to-Everything, or V2X, your car will literally talk to its surroundings. It'll know a traffic light 3 blocks away is about to turn red, allowing it to start regenerating energy perfectly smoothly, way ahead of time. Edge computing means there will be a supercomputer right in the car for instant decisions. This could even lead to vehicle-to-grid systems where your car's battery could help power the city during peak hours. And finally, explainable AI will make these systems transparent so we can actually understand why the car is making the decisions it's making. So, the big takeaway here is this. We are watching braking transform from a simple physical act into an intelligent act of creating and managing energy. Every red light, every bit of traffic suddenly becomes an opportunity to power up. Thanks to AI, the simple act of stopping is about to become one of the smartest things a car can do. Thanks for tuning in.